day to all dear students. In last video we have done some questions of exercise 10a Pythagoras Theorem chapter number 10. Now in that video we have completed up to question number 13. In this video we have to start with question number 14. Question number 14 is a ladder rests against a vertical wall at a height of 12 meter from the ground with its foot at the distance of 9 meter from the wall on the ground. So here first of all you have to draw one vertical wall and the ladder rests on it, so that the 12 meter height of the vertical wall, so that I have drawn as AB and I have written their wall 12 meter, and that 9 meter from the wall to the ground, that 9 meter distance BC from the foot of the ladder to the ground. And now further it is written if the foot of the ladder is shifted 3 meter away from the wall. So you can check now that 9 meter distance is B to C. Now 3 meter more it far away. So now CD distance is 3 meter which I have drawn, and so the ladder will become more slant. So how much lower will the ladder slide down? Means we want to find distance AE, which you can see in the figure. Now students, I have already written AC is a ladder, and in the figure you can see that ED is also a ladder. So ladder's distance or length will not be changed in any of the case. So in triangle ABC, first of all I have to find the value of AC. So using Pythagoras theorem, AC square is equal to AB square plus BC square, substituting values. So 12 square is 144 and 9 square is 81 is equal to 225. Now taking square root on both the sides, we get AC is equal to 15 meter, which is the length of our ladder. So students, now you have to think that first of all the ladder is at AC situation, and in the next situation the ladder is at ED situation, means ladder is same, so the length will not become changed. It means we can say that AC is equal to 15 meter, and that is the length of ladder, and ED is equal to AC is equal to 15 meter. Now in triangle EBD, that is the triangle made after we have drawn it more slant. So now in that triangle we have to find value of BE, so that we get AE. Okay, so ED square is equal to BE square plus BD square. So now we want BE's value, so I have made it as a subject. BE square is equal to ED square minus BD square. Now we substitute values in it, as ED is, we have just found 15 meter, and BD is 9 plus 3. You see BD is now changed as 9 plus 3, which become 12. So BE square is equal to 15 square minus 12 square, and the squares are 225 minus 144. So subtraction is 81, and finding square root on both the side, we get BE value 9 meter. Now you have to find AE value, that how much lower will the ladder slide down, so that the AE distance we want to find. For that we know AB value is 12 and BE value we have found 9. So we subtract this 9 from 12. So we get our AE value. So here you can see that AE is equal to AB minus BE is equal to 12 minus 9, 3 meter. So this way we have completed this question. Now move on to question number 15. In question number 15, AD is an altitude of a triangle ABC, and AD is 12 centimeter, then BD 9 centimeter, DC 16 centimeter. Prove that the angle BAC is a right angle. So here students, I have drawn the figure accordingly, in which AD is a altitude. Altitude is always forming 90 degree angle with your base. Base is BC here. So and accordingly BD is 9 and DC is 16 I have written. Now students, you have to think that BAC we have to show 90 degree. So how we can show? By using Pythagoras theorem. For that, first of all we have to find in triangle ADC AC distance, that we don't know. So we find AC square is equal to AD square plus DC square is equal to 12 square plus 16 square, which is 144 plus 256. The sum of them will be 400. So AC square is 400. So AC, if we want to find, then by taking square root on both the sides, we get AC value is equal to 20 centimeter. Now in the another triangle which is left to the height AD, so that is ABD triangle or ADB triangle, in which also we will use our Pythagoras theorem to get value of AB. So here AB square is equal to AD square plus BD square, and substituting values, 12 square plus 9 square, that is 144 plus 81, it become 225. So taking square root on both the sides, we get value of AB, and value of AB will be 15 centimeters. So students, we found here value of AC, value of AB, and value of BC is already we have found as 9 plus 16, that is 25 centimeter. So here we got all the three sides of triangle ABC, and now we want to prove that angle BAC is 90 degree. For that, using Pythagoras theorem, I will show that BC is the hypotenuse, so BC square is equal to AB square plus AC square. If this will prove, then only we can say that angle BAC is 90 degree. So I have written here, to prove angle BAC is equal to 90 degree, I will show BC square is equal to AB square plus AC square. Now AB value is 15 and AC is 20. So by squaring 225 plus 400, so the sum of them will become 625. So here we get our BC value 25 centimeter, which we already are given in the question, that 9 plus 16 also 25. So here we have shown our verification of Pythagoras theorem completed. So we can say that angle BAC is 90 degree. Hence we have completed our proof also by using Pythagoras theorem. Now moving on to next question. Students, 16 question is same as question number 15. You have to draw the figure as given in the question, and you have to draw a figure and use whatever we have solved in question number 15. Same method follow in question number 16 also. So question number 17, there is figure given in the question. So in the figure, here PT is altitude of the triangle PQR. You can see PT is altitude, PQ value 25, PR 17, PT 15, and QR is X. Calculate X. Students, in this textbook you are given printing mistake as it is PBR drawn, but it is actually PQR. So you have to check it thoroughly, you have to change what is B, you have to write there Q. Now you have to find X value. So you have to think that PT is the perpendicular or altitude. So first of all, there make two right angle triangles like PRT and PQT. So we can use Pythagoras theorem in this both of the triangles to get our QT value and TR value, and then we add them to get our X value. So by following this method, first of all I will use Pythagoras theorem in triangle PQT. So QT square is equal to PQ square minus PT square. Directly we need QT, so I have written accordingly. So 25 square minus 15 square is equal to 625 minus 225 is equal to 400. So QT we will find by taking square root on both the sides, as 400 square root is 20. So QT value is 20 centimeters. Now as we have found our QT value, we need to find TR value. So as you can see, QT is 20. Now in triangle PTR, the right hand side of PT's triangle, in which also I am using Pythagoras theorem, as PR square is equal to PT square plus TR square, and substituting values in that, like we want to find RT, so TR square is equal to PR square minus PT square. So here TR square is equal to PR square minus PT square, 17 square minus 15 square, 289 minus 225, the value we get is 64, and then taking square root on both the side, we get TR value 8 centimeters. So students, likewise we have found our QT value and TR value both. So to get our X value, we have to add them. So here we can see X is equal to QT plus TR is equal to 20 plus 8 is equal to 28 centimeter, which is our answer completed. Now question number 18. In question number 18, we are given AB 8, BC 6, AC 3 centimeter and angle ADC 90 degree, and the figure is already given in the question. So students, we have to think first by seeing the figure that how do we solve it. As you can see that CD we want to find out. So first of all, let CD is equal to X centimeter. That is unknown value, so you can choose at X. Now in triangle ACD, that is the smaller triangle, you see only two values are known to you, that is AC and CD. CD also not known, but you can use X there. So I have substituted values in that Pythagoras theorem. AC square is equal to AD square plus CD square, and 3 square is equal to AD square plus X square. So here AD square in the form of AD, I will get my answer. AD square is equal to 3 square 9 minus X square, which is first value of AD. Now in triangle ABD, that is the full big triangle, we will apply our Pythagoras theorem. As AB is the hypotenuse, so AB square is equal to BD square plus AD square. Now BD is what? 6 BC plus CD, that is X. So we apply here 8 square, substituting value 8 square is equal to AD square plus BD is 6 plus X whole square. Here also AD is there, so we write our answer in the form of AD square is equal to 8 square 64 minus 6 plus X whole square. This is our number 2 result. Now you have to just see that equation 1 and equation 2, left hand sides are same, that AD square. So we can compare their right hand sides to get our value X. For that, we are comparing equation 1 and 2 of right hand sides. So comparing 1 and 2 right hand sides, 9 minus X square is equal to 64 minus 6 plus X whole square. Now this 6 plus X whole square is A plus B whole square type of identity. We have to expand it and write minus y, because outside the bracket it is minus sign. So that will be minus 36 minus 12x minus x square. So now you can see on equal to side, both the side there is minus x square which will cancel, and 9 is equal to 64 minus 36 is 28 minus 12x. So now we want x value, so 12x we take on left hand side, so 12x is equal to 28 minus 9. So we get 12x is equal to 19. X value 19 upon 12, which we can change into mixed fraction as x equal to 1 integer 7 by 12 centimeter, which is our value of CD, which we have supposed as x. So this way students, you have to think that which is the common side in these two triangles formed, and using it you will get your answer. Question number 19, the figure is already given. In BAC is a right angle triangle, AD is perpendicular to BC, AB 4, AC 3. So we want to find BD value. For that, also in this triangle BAC is 90 degree. Now BC is the hypotenuse according to BAC 90 degree. So I am using here that whole triangle BAC Pythagoras theorem. So BC square is equal to AB square plus AC square, substituting values 4 square plus 3 square. So 16 plus 9. So BC I find BC square is 25, and by taking square root we get BC 5 centimeters. So here we come to answer BC is equal to 5 centimeter. Now so what about that CD value students? You have to think in the figure. Just check the figure. If BC is equal to 5, then and BD is equal to x. So CD is equal to 5 minus x. So I am using now in triangle ABD again Pythagoras theorem. So AB square is equal to AD square plus BD square, and substituting values in it, like AB is 4 and BD is x, and we do not know AD value. So we have 4 square is equal to AD square plus x square. Now AD square is equal to 4 square is 16 minus x square. We come to this answer because AD is the again common side of the two triangles formed here, ABD and ACD. So we will again find two different values of AD square and then we can compare them. So here now we use our Pythagoras theorem in triangle ADC. So moving on, we will just see the whole proof. So in triangle ADC, AC square is equal to AD square plus CD square, 3 square is equal to AD square plus 5 minus x. I told you that how the CD value found. BC is 5, BD is x, so CD is 5 minus x and whole square. So AD square is equal to 3 square 9 minus 5 minus x whole square. Now this is our second result. So you can see first and second result on the left hand side equal AD square only. So we can compare the right hand sides. So in the next step we are comparing the right sides of equation 1 and 2. So by comparing 16 minus x square is equal to 9 minus 5 minus x whole square. Now this 5 minus x whole square is a minus b whole square type of identity, which we expand like 25 minus 10x plus x square in the bracket, but outside the bracket there is minus sign, so we must change the sign in the bracket. So on the right hand side we have 9 minus 25 plus 10x minus x square. Now on left side and right side, both the side minus x square get cancelled. So 16 is equal to minus 25 plus 9 minus 16 plus 10x. So we need to get 10x is equal to 16 plus 16, which is 32. So x is equal to 32 divided by 10, and we all know that divided by 10 we get 3.2 centimeter our x value. So likewise we have completed our question number 19. Question number 20, figure is already given. You have to check that angle BAD and ADC are right angles and AX is parallel to BC, and AB is equal to BC is equal to 5, means side AB is 5 and BC is also 5, and DC is x. So you see DC is the big side in which we can say AB and XC are same. Why? Because they are opposite and parallel. So AB is equal to XC, I have written there 5, and similarly AX is equal to BC 5. So how much is dx value? As whole DC is 8, so dx will become 3 centimeters. And students, one more thing, that ABCX is forming rhombus here. This is our rhombus, and we need to calculate area of ABCX, which is rhombus, one kind of parallelogram. For that, in triangle ADX, you check ADX, we use Pythagoras theorem to get value of AD. Why? Because AD is the vertical height, that is why. So AX square is equal to DX square plus AD square, and AD square is equal to AX square minus DX square. Students, this you should now understand that whenever which value you want to find, accordingly you have to change your equation. So substituting values, 5 square minus 3 square is equal to 25 minus 9 is equal to 16, and taking square root on both the side we get AD is equal to 4 centimeters. Now you have to think, already you have studied in 8th standard that area of rhombus, which is one type of parallelogram. So it is base into height. Area of ABCX is equal to base into height. So base, you can see base is AB, which I have written in the bracket, and height AD, which we have just found, so that is 4. So 5 4s are 20 centimeters square, is our complete answer of area of ABCX. So here we have completed our exercise 10A. In next video we will start our exercise 10B. Thank you.